Aisha.Academy. So this is my first time going through the Edexcel 2021 assessment material, and this time I'll be going through algebra and functions, and tomorrow I will be going through the integration. So gradually I'll be going through the Edexcel topics as well as AQA, which I've already started. So let's get right into it. Okay, so the first question just basically says that given that x plus 2 is a factor of f of x, we need to find the constant of a. So if the factor is x plus 2, then we need to substitute x equals minus 2, because remember for x values, whatever's in your brackets is opposite usually. So we'd substitute x as minus 2 into this formula up above. So then if you've got something that's a factor of something, that means that if it's a factor, f of x would be equal to 0. So then that now means I'm going to do what I did before, where push the question to the side so I have enough space for working out. So I'll rewrite the formula as the question 1. So 2x cubed minus 5x squared plus ax plus a. So then if x is equal to minus 2, that would be 2 bracket minus 2 cubed minus 5 minus 2 squared plus, well, not plus, minus 2 times x would just be minus 2x plus, oh, not minus 2x, minus 2a, because minus 2 was x, plus a. So now that's equal to 0. Okay, so to work out what a is, just expand what we have so far. So minus 2 cubed would be minus 8 times 2, which is minus 16. And then minus 5 times minus 2 squared is 4 times minus 5, which is minus 20. And then you still have your minus 2a plus a is equal to 0. So if we rearrange that, that's minus 36. And then minus 2a plus a would be minus a. And then that would be equal to 0. So then we rearrange that. A would be equal to minus 36. So that's our final answer for that question. Then for question 2. So question 2, it says find GG5. So first of all, we need to find the formula for GGX. So I think I mentioned this before it was either a GCSE or another paper. Anyway, when you've got composite functions, think of it as like the outer letters like the mother and the inner letters like the baby. So normally for g of x, you've got 2x plus 5. For this one anyway, you've got 2x plus 5 and then over x minus 3. But if you've got GGX, your x's are replaced with your g of x. So then it would be 2. So rather than 2x, it's going to be 2 bracket your equation for g of x. So 2 bracket 2x plus 5 over x minus 3, as that's what's replaced x, plus 5 over 2x plus 5 x minus 3. And then that's take away 3. So you can simplify this. So now it'll be 4x plus 10. 4x plus 10 over x minus 3 plus 5 over 2x plus 5 x minus 3 minus 3. So then, again, we don't really need to simplify this any further, because now what we can do is we're just going to substitute the x's for 5, because we're trying to work out GG of 5. So then that's going to end up being 4 bracket 5 plus 10 over x minus 3 plus 5. Oh, why did I still put x? That should be 5. 5 minus 3, and then 2, 5, and then, yeah. And that was minus 3. So then expand everything, simplify. So 4 times 5 is 20, so 20 plus 10 is 30, and then 5 minus 3 is 2, so 30 divided by 2 would leave you with an answer of 15, and then 15 plus 5 would be 20. Then for the bottom bit, you've got the 2 times 5, which is 10, plus the 5, which is 15. And then, again, 5 minus 3 is 2, so 15 over 2. So then you've got 15 over 2 minus 3. Well, we know 3 can be written as 6 over 2. So now they have the same denominator. So then 15 minus 6 would be 9. So you've got 9 over 2. So 20 divided by 9 over 2. And then remember, whenever you're dividing fractions, you can flip them and become multiply. So then it'll be 20 multiplied by 2 over 9. So that'll be 40 over 9. And that would be that answer. And then to state the range, your range would be, well, it says here, which I don't know why that's come up like that, but it should say that for g of x, the domain is when x is greater than or equal to 5. So then what we would need to do is, first of all, looking at this formula, if when it's x is greater than or equal to 5, we essentially worked out that for the g of x formula here. So if you look at this part of it, because we know that that basically looks like that. And so with this range, one end of it will be where g of x is less than or equal to 15 over 2. And the reason why I say less than or 15 over 2 is because as the x value increases, the g of x value actually reduces. So I'll give you an example. So for instance, if x is 7, then if you were to substitute, that'll be 14 plus 5 over 4, so 19 over 4. But then if x is equal to 10, that would be 25 over 7. 25 over 7. And if you were to just quickly use your calculator to see that, we could see that, so 25 over 7 would leave you with an answer of 3.57, whereas the 19 over 4 leaves you with an answer of 4.75. So as we can see, as x value increases, the g of x decreases, and the number that actually is decreasing towards is 2. So that's why on the other end you've got 2. And the only reason I know it's towards 2 is because this, if I rewrite it here, so maybe if I zoom out. So the reason why it's getting closer to 2 is because I'll just put 2b. If we have a look, it's 2x plus 5 over x minus 3. Another way of writing that is 2 times x plus 5 over x minus 3. Because we know if you multiply a whole number by a fraction, it multiplies the numerator. So then essentially it's going to get closer to 2. So that's how you know it's getting closer to 2. So that's how we'd write our range. And then for C, we need to write inverse g of x to the minus 1. So when it comes to writing inverse, I'm going to rub this out. So when it comes to writing inverse g of x, what I normally do is replace g of x or whatever function it is with y, and then I write the formula. And then I so I swap all the x's and y's. So then that's going to leave me with now x is equal to 2y plus 5 over y minus 3. So then now I'm going to basically rearrange this all to make y the subject. And when I've made y the subject from this, that's going to give me my inverse gx. So it will be, I'm going to multiply both sides by x minus 3, then expand the brackets, then collect the y's together, collect the numbers together. And then, so now I have this, and then to simplify it even further, I forgot something there. I forgot to times x there. So it would be that. And then to make y the we'll factorize it with y outside the brackets. So then I have this. And then last step, just to make y is equal to, just divide both sides by x minus 2. So I'm left with 5 plus 3x over x minus 2. And so now, rather than writing it as y is equal to, I can replace that as g inverse g of x. And that is the equation. So that's just one part. Then it wants you to state the domain. So one thing I want you to remember is that the domain of a normal function is equal to the inverse range of a function. And so the range of a function is equal to the inverse domain. So because we know the range of the normal function, it is literally going to be the same as the domain of the inverse function. It's just rather than you writing g of x, you're going to write just your x. So it will be 2 is less than x, which is less than or equal to 15 over 2. Remembering this helps a lot. Okay, leave that for a few seconds and then we're going to move on. Alright, so question 3, it says, figure 6 shows a sketch of part of a curve with the equation y is equal to 3 times 2x squared. Sorry, times 2x. Yeah, the square of 2x. So I'll rewrite that. So then it says that point P, which is A, I don't know why that sign has come up. That should be PA 96 root 2. Lies on the curve and it wants us to find the exact value of A. So the best way of doing that really and truly is substituting the points on the coordinate into the equation to work out what A is equal to. So in the coordinates, A is our x value and then the 96 root 2 is our y value. So there's going to be 96 root 2 is equal to 3 times, rather than 3 times 2 to the power of 2x, it will be 3 times 2 to the power of our x value is a, so to the 2a. Okay, and then you're going to divide both sides by 3. And then that would leave you with, actually, I'm going to do the same thing as before, because I realize I do not definitely have enough space for working out there. That was question 3, but I'll just continue on from here. So then that would end up being, so remember when you're dividing surds, the surd's not going to change any of the numbers. So that's going to be 32 root 2 is equal to 2 to the power of 2a. And then now we're going to end up using logarithms to help us work this out. So remember the law, so if you have log ab equal to x, so remember that. So in this scenario, this is equal to, sorry, a to the power of x is equal to b. So in this scenario, the 2 is our a, so it's going to be log 2, and then b is equal to 32 root 2. And then the power is 2a. So that's going to be equal to 2a. Then they've really made a key point in this question. They've really said, in this question, you must show all steps of your working. Your solutions relying on a calculator will not be accepted. So you have to use your knowledge for this one. So in terms of working this out, you just really need to know your indices, especially for the powers of 2 really well. So first of all, let's look at the 32. So 32, another way of writing it in terms of 2 to the power is 2 to the power of 5. Root 2, another way of writing it is 2 to the power of a half. So if you have 2 to the power of 5 times 2 to the power of a half, remember when you multiply two base numbers, the powers, you add them together. That's going to be 2 to the power of 5.5, and another way of writing that is 11 over 2. So then it will be log 2 to 11 over 2 is equal to 2a. Then remember, if you ever have log a e to the power of something, another way of writing that is x log a b. So then you basically move the power to the front. So another way of rewriting this would be 11 over 2 log 2 is equal to 2a. And then the last step there would be that you would divide by 2. So then that would be 11 over 2 log 2. Actually, before you even divide by 2, one thing to note is also, just really writing all the log laws out here, if you ever have log base a, that is always equal to 1, because if you think about it, if a is to the power of 1, or anything to the power of 1 is itself. So if you ever have log and the base number, and the number next to it is the same, it's equal to 1. So therefore, if we've got log 2, that's going to cancel out to become 1. So then you end up just with 11 over 2 is equal to 2a. So then to work out what a is, you're going to do 11 over 2 divided by 2. Remember, if you divide, it's the same as multiplying it by a flipped over fraction. That will be multiplied by half. That will be the same as saying 11 over 4 is equal to a. And that's the exact value for it. So you could either write it as 11 over 4, or you can literally write it as 2.75, because either way, that's that exact value. Then I'm going to, so if you wanted to rewatch that, just just backtrack the video, because I'm going to rub this out now, just so there's enough space. Okay, so for question 4, it says that the curve with the equation y is equal to 3 times 2 to the power of x meets with the equation y equals 15 minus 2 to the power of x plus 3, x plus 1 at the point P. So it wants us to find, using algebra, the exact coordinate, x coordinate for P. So if both of these equations are going to meet at the same point, the best thing realistically is to make the equations equal to each other. So we're going to make 3 times 2x, 2 to the x, equal to 15 minus 2 to the power of x plus 1. Okay, so now that we've made them equal to each other, what we're going to do is we're going to move the 2 to the power of the x plus 1 to the same side as 2 to the x. So that will be 3 times 2x plus 2x plus 1 is equal to 15. Then we are going to factorize. So they both have 2 to the x as a common factor. So then the first one would have 3 in the first bracket. And then another way of writing, 2 to the power of x plus 1 is writing it as 2 to the x times 2 to the power of 1. Because remember, if you multiply 2 powers with the same base number, it's the same as adding the powers together. So that's the same as writing 2 to the x times 2 to the 1, but anything to the 1 is itself. So that would end up being plus 2 is equal to 15. So then now we have 3 plus 2. That would end up just being 5. So then 2 to the x times 5 is equal to 15. Then 2 to the x, if we divide both sides by 5, we get 3. So then to work out what x is, again, we would write it in a log form. So again, based on this rule, you're honestly, like, please, I hope you've learnt this by now, because knowing this will honestly save your life. So then that would now rearrange to x the power is equal to log 2, 3. Okay, and that's that final answer in its exact form. We would not write it as a decimal because that's not exact. Right. Then moving on to question 5. So question 5 says a curve has an equation y equals f of x, and it says given that f dash x, so f dash x is basically where it's dy by dx. So it's dy by dx is 6x squared plus ax plus, minus 23 is giving us the y-intercept of the actual equation of f of x, and it's told us that x plus 4 is a factor of f of x. So it wants us to find in the simplest form the actual equation of f of x. So the first thing is that if we've been given the dy by dx, to find f of x, we need to integrate. So we're going to integrate, so I'll put question 5. We're going to integrate 6x squared plus ax minus 23 by dx, and then that would leave us with 6x3 over 3 plus ax squared over 2 minus 23, and then our plus c. But then, because it's told us that the y-intercept is minus 12, for this now we know our plus c is minus 12. So now I'm just going to simplify what we have so far. So that will be 2x cubed plus a half ax squared minus, oh, I forgot the x on the 23, minus 23x minus 12. Then, because we know that x plus 4 is a factor, if we substitute in x is equal to minus 4 and make this equation equal to 0, that would help us to work out what a is, so then our f of x is complete. So then 2 bracket minus 4 cubed plus half a minus 4 squared minus 23 half a minus 4 squared minus 23 bracket minus 4 minus 12, that's equal to 0. So then minus 4 cubed would be minus 64 times 2, which is minus 128. And then minus 4 squared is 16, half of 16 is 8, so that would be plus 8a. And then we have 23 times 4, which is 92, but then because 2 negatives, it'll be positive 92, and then minus 12 equal to 0. So then now if we rearrange this, so let's have a look. So 128 minus 128 minus 12 would leave us with minus 140. So then if you did minus 140 plus 92, you would be left with, so 140 plus 90 is 50, well, minus 15, and then plus the 2 would be minus 48. So then that would be minus 48 plus 8a is equal to 0. And then we know that 8 is a common factor between 48 and 8, so then 8 bracket minus 6 plus a is equal to 0. So then minus 6 plus a is equal to 0. So then a is equal to 6. So then the final formula will be 2x cubed plus, so rather than writing a half 6, you can just, so a half times 6 would be 3. So then plus 3x squared minus 23x minus 12. So that is what f of x is equal to. Okay, and then having a look at question 6. So question 6 has given us an f of x equation. It says calculate when x is equal to 2. So then we're going to substitute that in. So then if we're substituting when x is equal to 2, so that'll be, again, I'm going to write on this side so I have enough space. So, okay, so that'll be 3 bracket 2 or minus 3 bracket 2 cubed plus 8 bracket 2 squared minus 9 bracket 2 plus 10. Alright, so 2 cubed is 8 times minus 3, which is minus 24. And then 2 squared is 4 plus 8, which is 32. And then 9 times 2 is 18. And then plus the 10. So then to now solve this, so then minus 24 minus 18 is minus 42 plus 10, which is minus 32 plus 32, which is equal to 0. This is actually equal to 0. So Okay, then it says write f of x as a product of two algebraic factors. So since we know that when we substitute 2 and it's equal to 0, that's going to tell us that one of the factors is x minus 2. So then now, to work out the other factor, we can use the factor theorem. So it's x cubed. Oh, it's minus 3 x cubed plus 8x squared minus 9x plus 10. Okay, so now what we need to do is, so because we can see that between minus 3x squared, sorry, minus 3x cubed, if we were to divide that by x, we would end up with minus 3x squared. So that's going to go onto the top. And then now that we've worked that out, we're going to multiply the minus 3x squared by x and minus 2. So that would give us minus 3x cubed plus 6x squared. Take them away from each other. So then the minus 3x squared would end up cancelling out. And then we would be left with 2x squared. So then now, again, you're going to do the 2x squared divided by x, which would leave you with 2x. So then now you're going to multiply that 2x by the x minus 2, and that would give you, and bring this down. So that'll be 2x squared minus 4x, and then take them away from each other. That would, so the 2x squares end up cancelling out, and then you'd end up with minus 5x, and then bring the plus 10 down, and then minus 5x divided by x is just minus 5, and then now you're going to multiply that minus 5 by x minus 2, which will leave you with minus 5x plus 10 as well, and then take them away. That gives you 0, which means the two algebraic factors are the x minus 2 and this bit up here, which is the minus 3x squared plus 2x minus 5. Okay, and then for part B, it wants us to prove that our answers to part II prove that there are only two real solutions to this equation below. So the difference between this equation here and the one that they've given up here is that other than them replacing it with y's, so they've replaced x with y, and also look at the powers. The powers are like double, right? Meaning that they've squared it. So they've basically done y squared instead. So the thing is, when you have two real roots, that means your discriminant, which is b squared minus 4ac, we need to try and see whether the value of the discriminant is going to be greater than 0, equal to 0, or less than 0. So let's work it out. So with our discriminant, first of all, we're going to be using the minus 3x squared plus 2x minus 5. So we're going to be using that equation. So with this, because this is the quadratic algebraic factor and discriminant is good for quadratic formulas. So in this, our b value is equal to 2, our a is equal to minus 3, and our c is equal to minus 5. So then now, if we substitute that in, so then that would be, so b squared, so that would be 2 squared minus 4 times minus 3 times minus 5. Okay, so then working that out, that would leave us with 4 minus, so then 4 times minus 5 is minus 20 times minus 3, which is positive 60. So then 4 minus 60 is equal to minus 56. So then, but the thing is now, our discriminant is giving us a value, because we got minus 56, it's giving us a value which is less than 0. So essentially from that quadratic part, there's no real roots. which means the only real roots so far is the x minus 2. So then, therefore, x minus 2 is the only real root, because the other ones, like it gave a negative value for b squared minus 4ac, so it shows that none of the roots come from the quadratic part of the algebraic factor. So then to now actually show the actual real solutions for it, well, in this formula, essentially, rather than it being y is equal to x minus 3x cubed, we've essentially got x is equal to minus y squared, well, essentially the y equation squared. So then we have x is equal to our y equation squared. And then, so because x minus 2, that essentially is x is equal to 2. So then 2 is equal to y squared. So then y is equal to plus and minus root 2. So essentially, these are our two solutions, two real solutions, positive and negative root 2. And I hope that makes a lot of sense. Okay, so I'll leave that for a bit and then I'm going to rub it out. And then on to part C. So part C says deduce the real number solutions for, I don't know why there's a pound sign there, but it really should be a less than or equal to sign. So I'll rewrite it up here. For 7 pi is less than or equal to pi, well, equal to theta 10 pi. So then it wants us to find the real number of solutions. Well, again, this tan equation looks very similar to the equation up above. It's just replaced the x's with tan. So in this scenario, because of that, and we know that the real roots were when x is plus and minus root 2, we're going to replace tan theta, or we're not replace, but we're going to say tan theta is equal to 2, because from this bracket x minus 2, we know that x is equal to 2, but rather than x, they've written it as tan theta, so tan theta is equal to 2. And so to find out the number of real solutions, from a bit of recap with your tan graphs, especially in radians, because we've got a bit of pi going on. Pi over 2 and pi. So remember, your pi over 2 is like equivalent to your 90 degrees, and then your pi is equivalent to your 180 degrees. The whole point, just for recap, so when it comes to tan, so you never have it touching 90 degrees, but then you have solutions in between. Okay, so if you have solutions between, so for instance, between 270 and 90 degrees, that's a gap of 180 degrees, aka every pi. So for every pi value, you've got a solution. So if you've got from 7 pi to 10 pi, we're going to have 3 solutions. And I just wanted to draw that out to make that make sense. 3 solutions due to 1 solution every pi. So yeah, I just wanted to draw that out to make that clearer. So that's how we would answer question 6. Okay, so moving on. So question 7, it basically says that f of x is equal to 2x squared plus 4x plus 9. And it wants us to write f of x in the form of a bracket x plus b squared plus c, where a, b, and c are integers. Okay, so we're going to be completing the square. So then question 7a, so that's 2x squared plus 4x plus 9. So the first thing is we're going to divide everything by 2. So that will be 2 bracket x squared plus 2x plus 9 over 2. Then we are going to complete the square with the x squared plus 2x. That will be x plus 1 squared. Take away the 1 and then plus the 9 over 2 on the outside. So then that would be 2 bracket bracket x plus 1 over 2. So then minus 1 plus 9 over 2 would be plus 7 over 2. So then now we've got the plus 7 over 2. The last bit is just multiply the 2 back in. So then that would be 2 bracket x plus 1, but then remember to multiply that 2 by the 7 and the 7 over 2, and that would change it into 7. Okay, so then now we've got that, that would be our final answer. And then part B wants us to sketch the equation, sketch the curve with the equation y equals f of x showing any points of intersection with the coordinate axes and the coordinates of any turning points. So, first of all, we are going to draw a little sketch. So let me move this out. Okay, so first things first, from completing the square, which I'm going to scroll up a bit, just so we can see the formula. So then it was this. Okay, so with completing the square, the point here and the point here give you the coordinates of your turning point. Usually what's inside the x brackets is actually the opposite of what is the actual coordinates of the turning point, meaning that if it says x plus 1 in the brackets, then the actual x value for the turning point is -1, and then the y is just 7. So this is for our turning point. So then if I quickly sketch a graph, so that's -1 and 7, so there'll be something there. And again, it's a quadratic graph, so something like this. And then, so we've worked out the turning point, then we would need to work out the other points on the coordinate axes. So we can see that it crosses the y-axis. So at that point where it crosses the y-axis, y is equal to 0. And it doesn't mention it crossing, sorry, not y is equal to 0 at the y-axis, x is equal to 0. So then we can substitute x is equal to 0 into the formula. So that'll be 2 bracket 0 plus 1 squared plus 7. So 0 plus 1 is just 1. So 1 squared is 1, and then times 2 is 2. 2 plus the 7 is 9. So then the coordinate where it crosses the y-axis, we can happily say 0, 9 for here. And then we've got the turning point, which is -1, 7. And that's it. We can't see it cross the axis again. So that's pretty much all our points of intersections and the coordinates of the turning point. Then it wants us to describe fully the transformation of the curve with the equation y is equal to f of x onto the curve with the equation y equals g of x. So it's given us y equals g of x. So let's have a look. So comparing it to the first equation at the top here, we can see that in the x it's shifted. So if it says -2 in the brackets, it's really and truly +2. So it's actually added 2 onto the x value, and we can see the y values changed as well. So let's try and figure out our working out for this question. Okay, so I'm going to again move it to the side, and then for 7c, so I'll write the original formula here. So it's 2x squared plus 4x plus 9, and it's now changed to 2 bracket x minus 2 squared plus 4x and -3. Okay, so first things first, it's shifted in the x-axis, so +2. And also we need to add that x minus 2 bracket to the 4 as well. And then it was -3. So now if we really simplify that, it would end up being 4x minus 8 minus 3. So then 4x minus 8 minus 3. So then because we're trying to end up with -3, we actually need to add this 8 on to the minus 3. So 8 plus minus 3 would be positive 5, and I'll explain why. Plus 4x minus 2 plus 5. Because if we were to expand this, we get the minus 8, and then if you did the 5 minus 8, you get the minus 3. So then the whole point was just working out that the 8 would need to be added on to minus 3 to make sure, if you're going to rewrite it in the way of where you've got 4 bracket x minus 2 rather than 4x. So then now, comparing this to the original equation, we can happily say that it's being translated by the vector. So the vector will be positive 2 because it's actually plus 2. So remember, what's in the bracket is opposite. Now, comparing the y values, we've got 9 and we've got 5. So it's actually gone down to minus 4. So remember, y is not the opposite. Well, this is legitimately what has happened. And then the last bit says work out the range. So I'm going to rub this out. So for the range, which is CII, we've got h of x is equal to 21 over 2x plus 1 squared plus 7. So, well, it's basically this formula, which was the original formula, which that was the complete in the square format of it. So, as we can see from the complete in the square, we can see that the minimum value is 7, which we can see from the graph. So, in knowing that, we know that the highest hx value, if it was based on the minimum point, which is 7, so 21 over 7 is equal to 3, and so we would know that the highest value would be hx is equal to or less than 3, but then the lowest hx value is if you have the denominator is 0. So if you have the denominator 0, 21 divided by 0 is 0. So then it can basically range anywhere between hx is basically between 0 and 3. However, it's not actually equal to 0. It's just anything greater than 0. So that would be the final answer for your range. Okay, so that's how we would answer question 7. So having a look at question 8. So let me rub this out. So when it comes to question 8, we basically got algebraic fractions, and it wants us to solve for the values a, b, and c. So we're going to do that now. So I'm going to rewrite it at the top here. So 11, oh no, let me rewrite the question first. N plus 11x. Okay, so we're going to rewrite this. So basically, if you look on the right hand side, anything, so for instance with A, it doesn't have any of the factors underneath, so A would be multiplied by both of them. So whatever is not shown underneath it, that's what it's going to be multiplied by. So if B, it's got x minus 3 underneath, so it's going to be multiplied to 1 minus 2x, and then C, x minus 3. Okay, so now we've done that. We're going to be comparing coefficients. So let's have a look at minus 6x squared. So the only x squared here is when you've got x times minus 2x squared, which would be minus 2x squared a. So then cancel the x squares, you've got minus 6 is equal to minus 2a, so a is equal to 3. So now we know what a is, we need to work out what b and c are. So let's form the other equation. So for 11x, you're going to have, when minus 3 is times by minus 2x, you get plus 6x, and then x times 1, you get plus 7x, plus 1x, which gives us 7x. So that'll be 7xa. And then here we've got the minus 2xb, and then here you've got plus cx. So then we can cancel out all the x's. So that's going to leave us with 11 is equal to 7a minus 2b plus c. And then for the next equation, we're going to have 1 is equal to, so we've got when minus 3 times 1, that gives us minus 3, so that'll be minus 3a, and then you've got when b times 1, so plus b, and then you've got when c is times to minus 3, so minus 3c. So these are the equations that we have so far. So what we're going to do is solve them by simultaneous equations. So times that whole bottom one by minus 2, and that would be, so the 11 one is not going to change, but the 1 by minus 2 will be minus 2 is equal to positive 6a minus 2b plus 6c. Take them away from each other, well, that ends up being 13 is equal to a, the 2b's end up cancelling out, and then minus 5c. And then because we know that a is 3, we're going to substitute that in. So 13 is equal to 3 minus 5c. So then take away 3, it's going to be 10 is equal to minus 5c. So then c is going to be equal to minus 2. So we know c is equal to minus 2. Then to work out what b is, we're going to substitute the value of c and a into one of the equations, so into this one. So 11 would be equal to 21 minus 2b minus 2. So then 21 minus 2 is 19. 11 minus 19 is minus 8. So minus 8 equals minus 2b. So then b is equal to 4. Now for part B, which I'm going to rub out. So with part B, we need to prove that f of x is a decreasing function. So we're going to write out the algebraic fraction of what we just solved. So minus 2, 1 minus 2x. Okay, so when it comes to proving f of x is a decreasing function, we basically need to work out the differential and show that that is less than equal to or equal to 0. So dy by dx of this would be, well, the 3 would go. The 4 over, actually, let's rearrange this first. So another way of writing this is y is equal to 3 plus 4 bracket x minus 3 to the minus 1 minus 2 bracket 1 to minus 2x to the minus 1. Now, if we work the differentials, the 3 is going to go, that's going to change to minus 4x minus 3 minus 2, and this will change to plus 2, 1 minus 2x minus 2. Okay, so now that we have this, the next step is to show that this would be less than 0. Well, let's rewrite this. So this would be written as, okay, so as we can see, so normally x squared is greater than 0. But in this scenario, we've got minus 4 over x minus 3 squared, which will be less than 0. So because we have this function, which is less than 0, and even though you've got the plus the 2 over 1 minus 2x squared, because of the minus 4 over x minus 3 squared, we can say that therefore f of x would be a decreasing function. Yeah, so something along those lines. So yeah, I'll just leave that there. Okay, so moving on to question 9. So then we've got the equation. So I'll rub this out. So question 9, we've got the equation y is equal to k minus 1 over 2x. So then in terms of sketching this graph, So having a look at the equation, we've got, first of all, 1 over 2x, which is going to be a reciprocal graph. But because, oh wait, it should normally be, but because we've got minus 1 over 2x, it's going to be the other way. And then k is just going to be a constant, so a point where it would cross the y-axis. And then the other way as well. So like this, with k being the constant. So then, yeah, points of intersection, so k would be one of them. Also, there's no other point of intersection, but we can happily say that the asymptote, the line that's not really touching, is the x-axis. So, and the equation for the x-axis is y is equal to 0. So asymptote y equals 0, and intersection k 0. Okay, and then yeah, so that's that part. Then it says the straight line L has an equation y equals 2x plus 3, and it says given that L cuts the curve in two distinct places, find the range of values of k, writing your answer in set notation. So the first step of doing that is that, so if I again am about to create some space, so first things first, you want to make this equation and this equation equal to each other. So that would be k minus 1 over 2x is equal to 2x minus 3. So now that they're equal to each other, the next thing that we're going to do is that we want to multiply everything, well, both sides by 2x. That will leave you with 2xk minus, so the 2x times the 1 over the 2x, so that will end up cancelling out. So then that would just leave 1. And then that would be equal to 4x squared minus 6x. Okay, so now that we've done that, we're going to bring everything to one side. So then that would leave us with 4x squared minus 6x minus 2xk plus 1 is equal to 0. And then we're going to collect the x's together, so that'll be 4x squared. I'm just going to write this in a straight line. So that will, so it'll be 4x squared and then minus outside, and then the common factor between 6x and 2x is 2x, so 2x, and then it'll be the 3, and then plus k. So 1 equals 0, so then we know that now we have a quadratic formula. Our a value is 4, our b is equal to 3 plus k, and our c is equal to 1. So now we're going to substitute them into quadratic formula. Specifically, we want to substitute it into the root b squared minus 4ac, because we know that part is the discriminant. And we know if that's greater than 0, that gives us our two roots. So by doing that, that would leave us with, so root 3 plus k squared minus, and then 4 times 4 times 1. So that'll just be minus 16. So then if we expand our brackets from the 3 plus k squared, that will be k squared plus 6x, sorry, not x, plus 6k plus 9 minus 16, and then that would be the root of k squared plus 6x plus 6k. So 9 minus 16 is minus 7. So now we have that. So then now we know that this is what our discriminant is. We therefore know that that part, so the k squared plus 6k minus 7, because we have two distinct roots, it's going to be greater than 0. So now to solve this, it would be k plus 7, k minus 7, k minus 1, if we solve this by factorizing double digits. So then our values of k is equal to minus 7 and 1. And so to write this in a set notation, you could write it as this: k, and then the colon, minus 7 less than equal to k less than equal to 1. And that's that. That's it for that one. Okay, then moving on to question 10. So question 10 has an equation. Again, I'm going to rewrite it because it's come out quite strange. So for question 10, the equation is 2 because it's a modulus. And then it was x is greater than equals to 0. Okay, so and now I'll put this out since we've done with this part. And yeah, just to separate them. Okay, so now that we have question 10, it says state the range of f. So the range of f is quite nice with modulus, as you can see on the graph. It would be just anything from the minimum point. So it's going to be, got to write f of x there. Yeah, so then the range will be f of x is greater than or equal to 5. Since 5 is like the lowest point based on the modulus. So that is that part. And then for part B, it says solve the equation. So the equation is not that. The other equation here is, yeah, actually, no, it is quite clear. So it's f of x is equal to half x plus 30. Just ignore the half here. So then in terms of solving it, we need to make this equation and this equation equal to each other. So by making them equal to each other, we would end up having minus 2. Oh, minus 2 now, by the way. So minus 2 bracket, I'm just going to rewrite this so no one gets confused. Okay, so minus 2 bracket 3 minus x plus 5 is equal to half x plus 30. And then if we expand the brackets, that'll be, so now the key thing here is that, oh, there's no minus there. I don't know where I got that from. Okay, so the key thing here is that when you've got a modulus, you've got the negative values becoming positive, and then you've just got the normal positive values. So we're going to expand this one normally, which would be 6 minus 2x plus 5 equals to half x plus 30. Bring everything to one side. So 6 plus 5 will be 11, and then 11 minus 30 will be minus 15. And then the minus 2x minus half x will be minus 5 over 2x. And then it was minus 19 equal to 0. So then x is equal to 19. Well, 19 divided by minus 5 over 2. But remember, for fractions, if you divide fractions, multiply it flipped. So then that's why you get negative 38 over 5. So that's one of them. Then the other solution is, because you can also get negatives in modulus that turn positive, you can have it now with the -2. I think that's where I jumped ahead of the gun. Okay, so now we have that. We're going to expand this. That'll be -6 plus 2x plus 5 is equal to half x plus 30. So then -6 plus 5 would be -1. And then -1 minus 30 would be -31. And then the 2x minus a half would be 3 over 2x. So it would be 3 over 2x minus 31 equals 0. So then x would be 31 times 2 over 3. And that would be 62 over 3. Okay, so 62 over 3. So then now that we've worked out the solving, we'll just put x is equal to -3, 30 over 5, and 62 over 3. Okay, and then moving on. So in part C now, it says given that the equation f of x is equal to k, where k is a constant, it wants us to work out the set of values for k. So because we worked out the two values of x's, aka our two distinct roots, we are now going to substitute that into the easiest formula, which would be the half x plus 30. Substitute the two values of x's, and that's going to give you the two values of k. So then we would be able to create a set for the values of k. So first of all, we could look at when x is equal to 62 over 3. So that will be a half times 62 over 3 plus 30. So if you were to solve that, you would end up with 242 over 6, which could be simplified into 121 over 3. And then when x is equal to minus 38 over 5, so that would be a half times minus 38 over 5 plus 30, which would leave you with an answer of 262 over 10, and that would be simplified into 131 over 5. So then our ranges for our values of x, this time we don't have to put it in, k, this time we don't have to put it in set notations, so it'll be 131 over 5 is less than or equal to k, which is less than 121 over 3. Okay, and then moving on to the last question. So last question is question 11. So first thing, it's showing a trajectory of a rugby ball. It says the height of the ball above the ground is h meters, and it says it's been plotted against the horizontal distance x, measured from the point where the ball is kicked. It says the ball travels in a vertical plane. The ball reaches a maximum height of 12 meters, and it hits the ground at the point of 40 meters from where it's kicked. So it wants us to find a quadratic equation linking h with x that models this situation. So what we can do is we can actually find the coordinates of some points of this shape. So we know down here we've got the coordinate 40, 0, here is just 0, 0. And here at the top where it's reached, because we know that it reaches maximum height halfway through its journey, so that would be 20. So this would be 2012. Okay, so now we know that, what we can write is, first of all, in terms of our two ways of working out h, we know that when h is equal to 0, so down here, the two solutions that we have for x is 0 and 40. So then our solutions can either be when x is 0 or when x minus 40. So you can either write it like that, or another way that you could write it is x and then 40 minus x, because it does look like a negative quadratic, because then you've got a minimum sorry, you've got a maximum point rather than a minimum point, which you would normally have with a positive quadratic. So then there's that. And then, so now that you've made your equation with h, the problem is that we've got this coordinate 2012 that we have to include. So then we're going to have a constant a. So I'm going to use the top equation. I was just showing you both. Either way that you would have written it is, that would have been acceptable. So then, now that we have this constant a, we kind of need to work out this constant in order for our formula to be complete. So to work out a, we're going to substitute the coordinates of 2012. So then at that point, so h is 12, a we're trying to work out, we know x is 20, and then you'd have 20 minus 40, so then it'll be 12 is equal to 20a times minus 20. So that would leave you with 12 is equal to minus 400a. So then a would be equal to 12 over minus 400, which would simplify into 3 over 100, so negative 3 over 100. So then the final formula would be h is equal to negative 3 over 100 x, and then x minus 40. So that's our answer for part A. And then for part B, it says use your equation to find the greatest horizontal height of the bar from O. So using our formula that we've made, the height from O is now 3 meters. So we're going to substitute h as 3. So then it's going to be 3 is equal to minus 3 over 100 x minus 40, and then we can make the equations equal to 0, and that would leave us with, so the 3's would cancel out, and by the 3's cancelling out, you're left with 1 equals to minus 1 over 100 x minus 40. So then you can actually now multiply both sides by 100, and that leaves you with 100 is equal to minus x minus 40. So then now you've got 100 is equal to minus x squared plus 40x. And then we can complete the square. So by completing the square, so multiply everything well on this one. Okay, you would end up with plus 100. You could either complete the square or you can either solve this by quadratic formula, by the way, just to tell you that there's different ways of solving this. I'm just doing it on completing the square. So then there'll be x minus 20 squared minus 400 plus 100 equals 0. And then it will be x minus 20 squared minus 300 equal to 0. So now that we've done that, we can rearrange this. So that'll be x minus 20 squared is equal to 300. Square root both sides, you end up with x minus 20 equals root 300. So then x would be equal to root 300 plus 20. So then now if you put that into your calculator and work out to 3 significant figures, you should get 37.3 meters as your x value, and that's the 3 significant figures. Brill. So then the last bit, which is just part C, it just says give one limitation of the model. So there's literally loads that you could have chosen. So you could have said things like there's no wind or air resistance. You could have said so many things like the ball is being modeled like a particle. Literally, there's quite a few, so I'm just going to go with the ball has been modeled as a particle. And the reason why we know this is a problem because we know the weight of the ball is very different to a weight of a particle. So this may not be representative at all. So yeah, any of those points. So yeah, I hope this was useful. Sorry that it was a long video. I feel the questions were quite in depth and I wanted to spend my time answering them correctly. So yeah, hope this was useful and thanks for watching.